Hi, welcome to Digital Dialogs, your compact conversations on the future of technology. My name is Rene from Reply, and today we're going to talk about revolutionizing industrial robotics, a vendor-agnostic platform for developers. What a title! And I'm honored to have a special expert guest to talk about this, Georg Püschel. Hallo Georg, wie geht's dir?
Hi, thanks for having me, Rene. So I'm happy to be here and have a little conversation about what we are doing. We are going to have a launch on November 4th. Maybe it's already done after when we are going to broadcast this year. And I'm very happy to also talk about now our new products and about the company maybe. I'm very thankful. Hi.
Awesome. Well, exciting to hear about your launch. So let's talk about that a little bit later. But first of all, please introduce yourself to our audience. Like, what's your background? What are you doing? What is the company you're working for, and so on?
So I'm one of the co-founders of Wandelbots, basically an industrial robots company that we founded in 2017. I myself have a background in software engineering. I studied here in Dresden, Eastern Germany. And from a group of PhDs we had working together at the university at that time, we basically founded the company based on venture capital. We are now 120 people, have raised until Series C, also something about 130 million euro, to build basically something completely new in the robotics domain that is nowadays a robotics platform. And for long, we had also some hardware products that we dropped last year. So we had a little pivot. Now we're building purely software. Exactly. And yeah, I'm a local, going out from here to the world and spreading the word about what we are building. And at the moment, I'm basically a software architect at Wandelbots. That's my role. I moderate the things that have to be talked about between the teams, right? And fostering conversations about how we build software. Yeah, and also doing the founder things that no one else can do except the founders, because they need a bit bandwidth. That's a difficult and thing that yeah, that's my role.
Gotcha. Well, that's quite impressive also to hear about your journey in the last 7 years only, and the growth here is in particular here in Dresden. It's great to hear and to see startups actually flourishing here. And yeah, really curious to learn a little bit more about it. So let's actually dive into right now. Please explain what you're doing at Wandelbots with that new platform that is for industrial robot programming in the end, right? And how is that actually empowering developers and automation professionals to work with any robot? And I also I'm aware it's also kind of a developer or no developer but vendor agnostic, so you can use different manufacturers and combine those. So share a little bit about it, please, and tell us about this exciting platform because that sounds really good.
Yeah, so you already said it. The mission is to build the first vendor-agnostic platform for programming industrial robots, and that's a bit a longish name, right? So we are calling it Nova. The platform is called Nova, and it's basically about robotic arms, right? It's not about mobile robots that move around and are used in logistics, for instance. It's not about drones, and also not yet about humanoids. That will take some more years, right? It's about robot arms that you can attach tools to. So, for instance, gripper, welding guns, gluing dispensers, whatever you can think of. And it's very complicated to work with those machines. Of course, they have to be programmed. That's the nature of robots in general, because the difference to special machinery that you use in production is, of course, that you can program robots freely to build the whatever application you can think of. And even though the hardware of those machines is great and very progressive, the software lacks basically everything we have seen in the wild nowadays in SaaS, for instance. So it looks like the interfaces are very proprietary and they look like 30 years old. And every robot vendor, let's take for instance KUKA, ABB, Universal Robots, Yaskawa, Fanuc, there are so many. They are building their own interfaces, technical interfaces, their own UI, so humanoid interfaces, protocols, and also programming languages that also look like the imperative ones that we had basically in the 80s, because they just want to ease the use of the robots, but at the same time they are building very special things custom made for their machine, even though the robots have basically, they are sharing the same functionality. They move from A to B with different kinds of motions, and they can trigger signals with the PLC or so, right? There are some additional functionalities that bit ease the use of those robots in certain applications. But in general, they are doing all the same. And so basically, there is no homogeneous interface to those vendors' specialities. And what you cannot do with those robots because of this, let's say, very proprietary things, is that you cannot build very smart applications with that. And our new platform, Nova, that is basically targeting two different kinds of engineering people. One is automation engineers, and for who we serve one single interface and programming language to control their whole fleet. So no matter what vendor the robots are from, and starting with a virtual robot that you can program online and then set up a new robot powered production cell. And the second target audience, so to say, is software engineers would like to build new applications on their robots. So, for instance, just imagine you're a service company that has built logistics cells for years. So, but all this in projects. And now you really would like to productize your know-how that you gained during those projects and build your own, let's say, production cell that does logistics. So you mount a robot on an axis, you have a conveyor belt, you have, let's say, some pallets that you place besides the robot, and now you're dropping in the packagings, and the robot should basically assemble them on the pallets, right? And if you now build that standard hardware cell for your customers, the customers, of course, now need to set up the geometry of their packagings, the speed of the applications, the interaction with other machines on their own, and you need a great user interface for that. And to build that, and also not to take too much time to build a software system from scratch, you can use our product to build such cells. And what we basically provide to the software engineers to do that are, first of all, a SaaS-like access to virtual robots, open API things that bridge the OT-IT gap. So basically the gap between the proprietary technology that you use in operational technology to what you are used to in IT, or like web interfaces, right? Development tooling, SDKs, for instance, designing front ends and deployment mechanisms for that apps that you build. And that all that together makes the platform character of Nova.
Yeah, that's pretty amazing, I think, and it's also cool that you allow various user groups, or well, not user groups, but different users and their personas to actually use that platform, and also provide the the right tooling for them. You also mentioned a programming language. Is it natural language that you can use for programming in these time and ages, or is it like a specific common programming language that you have chosen that is well known in the automation field, or what is it?
So basically, we built our own custom language that generalizes a bit about the different, or among the different robot vendors.
Uh-huh.
It's a language that is very close to Python.
Okay, cool.
And but you can also use, of course, we have an AI agent in that. You can basically enter natural language and ask the agent how the language would look like, for which you really in the end program the robot with.
Hmm.
But the language that we are providing is called Wandelbots, and you can use it to program any kind of robot.
That's very cool. So obviously it has to be called Wantel scripts. Where else should it be, right? Like, obviously, yeah. So tell me about the platform, and the simulation aspect of it, because I think you also mentioned that you can first develop with a virtual cobot, with a virtual robot, and then apply this from sim to reality in the end, right, to the real one. And yeah, tell us a little bit about it, and also what is the aspect, maybe like tools with like NVIDIA Omniverse or things like that, and what are the advantages of this approach, like sim to reality?
Yes, sim to real, that is the term that most people use for that, right? So the idea is, of course, that you need to lower the risk that you have before building the actual physical robot production cell. So because when you, in the end, you build a table or any kind of mounting for the robots, and then you attach all the other machines, you connect the cables, you attach the gripper to the robot or whatever you have as an applications, and then something goes wrong. That's very bad, right? Even though maybe not everything goes wrong, but maybe the robot is not able to perform in the speed that you know to still maintain your batch frequency, for instance, right? So that is all bad. So therefore, you simulate production cells in advance before actually building it. And nowadays there is software to do that, and the best software on the market right now, in my opinion at least, is NVIDIA Omniverse, because you can build whole manufacturing scenes in a very highly accurate and natural looking manner that looks really like you're in a real production space. So it's very uh, real. And Omniverse has also capabilities in terms of physical simulation. So you can basically really simulate how things fall, how materials are bent, how liquids move, and all this. But it's a bit difficult to also very accurately simulate robot kinematics. So kinematics are those things that basically describe that you have different joints in your robots, different kinds of axes basically that you have to move. And of course, the robot has a repetition accuracy of some, I don't know, 0 dot something millimeters, right? For instance, 0.1, 0.15, 0.2 millimeters. And therefore, you have to simulate it very precisely. And you cannot go just with a coarse granular simulation like the robot it will hit the target with 1 centimeter. No, it's not possible. Because the workpieces are also, for instance, manufactured, molded, or whatever to very precise dimensions. And also, the robot, of course, has dynamics that you have to simulate. It can't go with infinite speed from A to B. That's not possible. That's only simulatable in a very digital fashion. So that's not real. So you need to simulate acceleration, for instance, right? Um, and also the problems that robots bring, that they have singularities, and that they cannot go through points or not always go through 2 points in a straight line, right? And to find out what are the problems in my production cell. And what we provide is basically that you can attach NVIDIA Omniverse as a simulation platform to our software stack that deals as a backend to simulate the robots precisely. You can also use the scripting language Wanderscript to program the robots how they should behave in the simulation. And then later on, still use the same programming script that you have used for Omniverse in a real physical robot after you downloaded basically the software into your on-premise installations that are disconnected to the internet. Maybe even in that case, it would still be very close to what you have used or what you have modeled in the simulation. Even though there will always be, of course, a simulation gap. It's never 100% the same like in the simulation. That is just by nature, right? And what you also, of course, could do if you already have a production line, um, then you could basically model a digital twin for your robot. And connect the data that comes from the robot through our software to Omniverse to have a visualization, analysis, and monitoring of your production line.
That's very impressive, and also with the NVIDIA Omniverse integration, like you're saying, I think you're betting on the biggest player there, and they're really pushing forward also with all the tools as part of Omniverse. And yeah, we're also
Yeah,
leveraging Omniverse, Isaac Sim, and a few others to run some
yeah,
sim to
exactly.
real stuff. It's really
Yeah, the only thing is that it's very difficult nowadays to compete with AI because basically simulation that you need to simulate things precisely and the GPUs that you use for artificial intelligence are both running on the same NVIDIA hardware. So you compete basically if you want to equip your customers or yourself for internal usage with GPU-based virtual machines, then you're competing on the market with GPUs, and we just hope that there will be a relief in a certain future. That's a bit of difficulty.
that is true. But I'm optimistic that the market dominance of NVIDIA will the market will regulate it, and we already see that when you look at or companies that are building, like other startups that are building very specialized chips, like accelerator chips for inference, like LPUs as they call them, like language processing units, like not just vector processing or tensor processing units, but specifically for LLMs. And so we will see more of those coming out, I think. And then, NVIDIA will still make GPUs, I'm sure. And so the market will get a little bit less stressful, I think, like when you want to acquire lots of GPUs and need that for your development. I'm optimistic on that. It's like capitalism; it will regulate itself somehow with the need. So that's cool, I think. I know you guys are also positioning your platform as the which we already talked about, the vendor-agnostic platform, and but there's also another platform on the market, an open source one, which is quite established, like ROS, right? The Robot Operating System, which is might be confusing for the audience. Like, how does it differentiate? So maybe you want to talk about some of those points, like what are the unique benefits of the Wandelbots Nova platform and what it offers for industrial automation compared to others.
Yes, of course, there is ROS, and ROS also has its place foremost in academia, right? So I know many people that are using ROS to build very fancy new software. But what we actually want is to lower the bar for people in the actual industry that are building real production lines, right? So if you would use ROS for that, it would be a bit complicated if you just want to use it for standard industrial robot arms. So I do not know any real automation engineer in service companies or in internal departments that, for instance, automotive industries that are the, let's say, the highest or one of the two highest automated industries. The second one is maybe silicon industry, right? That really use ROS for their production line. And the thing is that you basically, first of all, need to know how to compile some C++ applications. That's a hurdle, right? And even when you have done that, you're still not at the point where you can just build a great UI, right? That's actually the part of the whole setup that is missing. ROS is more a messaging architecture. It standardizes messages and it brings a lot of tooling from the ecosystems. For instance, Gazebo and all the simulation tools, debugging tools, of course, right? But you're not building a real application on it. But if you want to build something fancy new, for instance, you're building a new robot, right? Um, then it's great. So what we think is that our platform is bringing the productivity tools that software engineers now employ since years and maybe even decades to automation. So we as software engineers, we have, I don't know, we have Git, right? Version control. That's very old fashioned already now. We have IntelliSense when you're using our IDEs. Our IDEs are very beautiful. They help us a lot in organizing code. They can do refactoring, for instance. And we have nowadays we have even AI that helps us to write half of the code we don't have to think about anymore because it's all bloat. And all those things are basically capabilities that automation engineers lack. And part of the truth in our platform is that we also want to make those engineers more productive with better tools that we give them. And because you cannot just have that built for any kind of new robot, we basically do that for every robot vendor that is out there, right? So it's basically the platform approach, and yeah. So and the other things is that software engineers are often in charge to build great products on robots, and they don't want to think about the itsy bitsy details of how to configure or move it and ROS to control your hardware precisely. Uh, we prepare that basically for our users, and so that they can focus on the things that really matter to deliver the value of the application, right? They don't have to think about the hardware details. And ROS is, as I said, in our opinion, more for people that build really new stuff that are very close to still to, let's say, research, and use the built-in capabilities. More, that I would say also for mobile robots, basically, there is no way around ROS if you start with it, right? For instance, for the SLAM algorithms, that is something that you cannot avoid. You need to use ROS for that because ROS provides you with that great things that are built in. And also, we still like to have a conversation with ROS people, but because we don't want to exclude them from the platform, of course, we invite them to use our system, and also building connectors to ROS, of course, as we also like to educate people that are nowadays using ROS for our software stack. And yeah, be also a friend with that ecosystem. Just that our positioning is more to build really products, and ROS is for building very new, edgy stuff.
Yes. I get it. It's more like a streamlined end user, a more streamlined, good end user experience that you're aiming for, instead of having this wide flexibility that you can have with ROS, where you, like I said, you need to compile it yourself and do all these things. So it's not really well suited for end users, but it's more like a development tool or library that you can leverage. And like you're saying, you're building connectors, so you can still leverage it. But your aim is really having a great user experience for everyone to actually build cobot solutions, right?
True, that is exactly how we position ourselves, right?
Awesome. Well, that's also a great market need. Definitely, I fully agree. That's definitely not as easy as it could be, and a lot of the progress that we had in other spaces like software development and so on, as you don't see it. So you're bringing that back. You're bridging that gap in the end, which is awesome. And when you look into your little crystal ball for the future, maybe what future applications or expansions do you anticipate? In particular, when we think about humanoid robots, what could happen there?
So there are basically two sides of it. So for us as Wandelbots, right, we are building the platform thing, and we would like to provide basically a framework to build more and more robot applications that look very well, that basically people can very easily use, and that homogenize the market. So, but if you think of humanoid robots, that's a whole new story, because the difference between humanoid robots and the robot arms that we use is flexibility. So humanoid robots cannot have such a good repetition accuracy, of course, like the fully fledged industrial robot arm, but they can walk around and do very different things that you don't have to program them for, because they have an basically an AI kernel, whatever, right? Whatever you call it. And so they have one of the most important things of those robots are their hands, because the hands can basically, first of all, mimic human hands, so you can copy from humans. And the other thing is that they can use human tools. You have a knife, if you have a screwer, they can really use the tools that we already have. And therefore, they are very efficient in adopting new tasks. And when you now think of industrial robots, that's more complicated, right? You have to equip them with new tooling. You have to program them for that certain task. There is no AI yet to make them do what you want. They are very static. They are at a fixed place in the production, but therefore the quality, due to the high repetition rate and to the standardization that you reach with those robots, it's very high. So I would say those two things do not yet compete with each other. Um, but there is, so to say, a very undiscovered great market for humanoid robots that we cannot serve with industrial ones. And maybe that will also be one of the future ways how we do at Wandelbots, that we basically help with, yeah, giving those robots new skills. And therefore, of course, we also need to do much research, but that's still far future for us. And we also don't think that in productions, um, robots like the ones from Tesla, Figure, Boston, whatever, will already do production tasks that are relevant now for industrial robots in 5 to 10 years. That's very difficult. They will maybe start with things that are more done right now by humans.
Gotcha. All right. Well, let's see. It's an interesting field for sure, and we see amazing progress all over the place. From like you mentioned, just a few companies, but yeah, it's incredible. Like every other day, you look on the typical news sites, and then there's a new humanoid robot startup, and another one, and another one. Right. Let's see when they will solve it. I talked with the CEO of Amica of Engineered Arts, and they produced this humanoid robotic head kind of thing, and it's what he said is like all of them face a big challenge, which is the motors, and basically having the density and the energy density that a human muscle has is uncomparable with anything we have available, and so that needs to be cracked first and solved, and then we can talk about true humanoid robots. And so that might be the case, but we'll see. I mean, we also working with Unitree, for example, with the H1. It can lift around 20 or 25 kilograms, right? So that's already pretty good. If you compare it to for example, if you want to submit a DHL package, right? Yeah, you want to send one, the maximum you can select is 23 kilograms. That's because of, well, the drivers and so on, they should not carry that heavy loads, basically. And so if a robot can basically yeah, if it can go over that, right? And then I tell them, hey, oh, just bring me that, back of concrete to the third floor where I have to make a wall or whatever. And so already these kind of small things can be quite useful. But you're right, right? To have the true integration, like true humanoid robots, like around us, will take probably much, much longer than the hype is indicating at the moment. But yeah, that's definitely an interesting, exciting time.
Yeah, absolutely. So you're right. The carriage weight is, of course, a differentiator between humans and robots, right? If you want to replace human work that is maybe not that valuable because the humans basically suffer from those kinds of tasks, then it's good to have basically robots that can carry something below 30 kilograms, right? And if you want to have new tasks for the robots, then you need robots that are a bit more stronger. And yeah, and the progress, of course, in humanoid robotics is very fast, and that's also because of LLMs, right? That as there is kind of things like diffusion policies that help to leverage the new capabilities of LLMs for planning within the robot, right? The robot is better equipped to understand things and to make make out things for planning future tasks, right? That's all based on language models. And yeah, that's basically an inflection point right now. But still, we need some years to bring them into a real production line.
Yeah, yeah, fully agree. And like you guys are building a great platform there, and you will keep the extensions available to other platforms, so that sounds all really, really interesting. We could talk for many more hours, and I'm sure we will continue that conversation at a certain point, but thank you so much right now for joining us and sharing your insights today. It was very much appreciated, Georg.
Yeah, thank you very much for having me. It was a great talk.
Awesome. Well, and thanks everyone for joining us today for Digital Dialogues, your compact conversations on the future of tech. Watch our blog, follow our social media, and subscribe to the Reply Talks podcast channel on your favorite podcast platforms. You name them, we are available on all of those. And of course, if you want to listen to a previous episode, you can find them also on the podcast platforms, but you can also go to our website and check it there, and also our other podcasts. Until then, thanks for listening. Take care and see you soon. Bye bye.